Okay, for today's assignment, we are on page 145. We want you to do the right section. So explain the difference between a recursive formula and an explicit formula. All right, so for the recursive formula, I'm going to write it up at the top here. For recursive formula, the thing is, you must know all, I shouldn't say all, but you must know the previous terms in the sequence. So you need to know some information about the other terms in that sequence, because the recursive function formula just says, hey, if it starts off at 2, 4, 6, and then continues on, you can keep saying, oh, plus 2, plus 2, plus 2, so 8, 10, and 12. But for the explicit formula, which is nice, that you don't need to know, you do not need to know the previous terms. Like we were doing in today's notes with the home runs, the explicit formula, you don't need to know those. You can calculate any term that you want by using the explicit formula. Practice number 1 we wanted you to do. So Greta must volunteer 225 hours for a community service project. She plans to volunteer for 6 hours each week, and the sequence shown represents the number of volunteer hours she has left after 3 weeks have passed. So right now when I look at the sequence, we're starting off at 225, and they are decreasing. So this is a decreasing sequence, and when we say this sequence, when we say describe the sequence, it is considered to be arithmetic. Okay. And then tell me what's happening. It's arithmetic that with a common difference. So how is it decreasing? Of -6. Okay. Use a formula to determine how many volunteer hours Greta has left to fulfill her requirement after 33 weeks have passed and show our work. So using that explicit formula, after 33 weeks, we want to see where we are located. So to set that explicit formula up, we are got okay. So to calculate that, what we're looking at here is, if I could write this better, the 34th term, A sub 34. So that A sub 34 is going to represent the 34th term. We have the initial amount of 225 hours we're starting with, and we are decreasing by 6 each time for however many weeks we're talking about. And we're talking about 33 weeks, so 34 minus 1. So 225 plus -6 times 33 weeks. Go to your calculator, plug it in. 225 plus a -6 times 33. That gets me down to 27. So that is 27 hours that she has left to fulfill her requirements. So she's starting off at 25. What that looks like in our tables that we've been doing, that 225 is my first term of the sequence when we've worked 0 weeks. This is the weeks worked. And this is the term number, and this is my term value. So then it's going to decrease by 6 each time. So as we keep working weeks here, this is where that 219 comes into. Then the second week, we're down another 6 to 13, but that represents the third term. Which formula would you use to determine how many volunteer hours left have to fulfill her requirement after 40 weeks pass? And I would do the explicit formula here, again, like we did in parts B, because to do 40 weeks, I would need to know where is it at on 39 weeks. I got to know the previous term, and I don't know 40 weeks. It's kind of quick to calculate, as they showed us here the first couple weeks, but when you start getting large, go to the explicit formula. So it's going to be the explicit formula. So then let's actually calculate on part D what's left after that. So for 40 weeks, what we're looking at is the 41st term then. So 225, again, we're starting off at the initial, plus -6 is my common difference, times the number of weeks. So when I multiply that out and add it to 225, what I end up getting then is a negative number. You didn't do anything wrong, but what that tells me is that since it's in a negative category, what that tells me is Greta has already met her requirement. So as soon as she gets to 0 or negative, she's out of that 225 hours. So she's then done. So at some place before 40 weeks, she's met her requirement. So it's going to be around like 37 weeks or so is where she's going to be located to where she met her requirement of hours. Okay, and the other one we wanted you to do is review number 1. Determine whether each given sequence is arithmetic or geometric, and then write the next 3 terms of the sequence. So when I look at this next one, letter A, we're going from 3 to -12 to 48 to -42. Well, for that to happen, 3 to 12 to 48, I can follow that. That's some multiplication happening there, and it's multiplication of a -4. So in that case, because we're multiplying, this is considered to be a geometric sequence with a common ratio, we call it, of -4. And it's negative because the negative is going to make that switch from positive to negative, positive to negative, positive to negative. So now I keep multiplying by -4 and the next 3 terms. And what I'm doing here is actually then our recursive formula. Because I've got these 4 initial terms, calculating the next 3 terms is pretty easy. That's the recursive formula we are then using. So -192 times -4 gives me a positive 768. Times -4 is a -3072. Times a -4 is then going to be a positive 12,288. That's the recursive formula. Recursive formula is kind of my quick go-to one if I just need to know the next kind of quick terms in the sequence. On letter B, all right, 2.45 to 3.86 to 5.27. Boy, that's kind of hard to see if you're adding or multiplying here. Multiplying might be maybe not be obvious to figure out. So let's see about if, say, some addition is occurring here. So to calculate that, I'm going to go from 3.86 and subtract 2.45. And whatever that turns out to be, I'm going to keep my fingers crossed then that is what we call then my common difference, and that this is an arithmetic sequence. So this is 1.41. And now I can check to see, does 1.41 take me from 3.86 to 5.27? So go to your calculator, plug it in. That does check out. 5.27 plus 1.41, does it take me to 6.68? And it does as well, okay? So this means, because I'm adding and subtracting means is an arithmetic sequence, and we call it with a common difference of what we just found, which is 1.41. So the next terms in that sequence are going to be, okay, after 6.68, keep adding 1.41. I'm going to use, again, what we call the recursive formula here. So 6.68 plus 1.41 is 8.09. 1.41 is 9.5, and then plus 1.41 is 10.91. That's just using the recursive formula. I did not need to use my explicit formula like I did, say, on practice 1, because practice 1 wanted to know 33 weeks down the road, 40 weeks down the road. That's too much to fill out on a table. That's the explicit formula is nice. If I just need to know some quick terms after the sequence, use the recursive formula, keep adding on that common difference or keep multiplying with that common ratio. That should do it.